for this portion, we are going to look at the angles between lines and lines as well as a line and plane. And okay, so let's just look at the maybe angle between two lines. Okay, so suppose that we are, unlike vectors, right, which have direction. Okay, lines and planes are actually, remember that they are actually objects without direction. Okay, so they are actually plane really represents a set of points that fall in the same plane. Okay, lines, okay, they are all without direction. So an angle between the two such objects, right? Okay, usually, if we are not sure, what we do is we always refer to the acute or the smaller angle. We always refer to the acute or smaller angle. So the range of values between are always between 0 to 90 degree, right? So suppose that we want to define the angle between two lines. We are interested in finding the acute angle between A1 plus lambda M1 and A2 plus mu of M2. Alright, so we use two different parameters, and remember the two different position vectors, two different direction vectors. Alright, so we will let alpha denote the angle between the direction vectors M1 and M2. So if you think about how, then we know that cosine alpha will be equals to basically M1 dot M2 and the mod of M1 and 2. So if you are not sure, basically it just looks like that. Okay, if you have one line, right, the first line may look something like that. Okay, equals to, okay, this A, basically A plus A1 plus lambda of M1. Okay, and the second line will basically be line 2, which is R equals to A2 plus mu of M2. Okay, so the angle between the two lines, you can see that it could be that you are calculating this, or it could be you are calculating this, right? So it really depends, because lines they have no direction. So a lot of times you are subjected to where the direction where the M is facing. Okay, so here, how do we reduce such ambiguity? Is that we always take the acute angle. Okay, so of course, basically you know that, let's say, ideally if this is my M1 and this is my M2, definitely you know that the angle between two vectors, okay, cosine theta is definitely equals to M1 dot M2 over the magnitude of M1 multiplied by the magnitude of M2. Okay, but what if alpha is acute or right angle? Okay, so like in this case, right, ideally, for both lines, okay, you can see your M1 M2 is pointing out. Okay, then over here, very easy, you can mean just like the normal case where we have A and B, where both are pointing out, then it's just equals to cosine theta. Okay, you can see just equals to so-called instead of A dot B, I use M1 M2 over the magnitude of M1 multiplied by the magnitude of M2. Okay, but if it's obtuse, for example, you can see that the first direction vector is going in this manner, M2 is going in this manner, right? So if we were to strictly calculate the angle between the two of them, right, it will actually be this angle, right? Because remember, to calculate angle, they must be so-called the tail of one must be pointing to the tail of the other. Okay, so this will actually be the angle. So how do we make sure that in this case we are calculating the acute angle? How do we ensure that we're only finding acute angle? So in this case, what we do, right, is we actually got to take the modulus. Okay, so here we need to put in the modulus. We need to put in a modulus sign. So having the modulus, right, ensures that our cosine alpha is always positive. So when we put in modulus, right, we are always ensuring that so-called our cosine theta is always positive, right? So the cosine theta is positive. Remember the ASTC. This ensures that you always have that theta is in the first quadrant. Okay, of course, cosine theta positive, theta can be in the first or fourth quadrant, but fourth quadrant in this case doesn't apply, because we are talking about two angle between two lines. It cannot be from 270 to 360 okay, so we are ensuring that we're making it positive. Okay, want it to be in the first quadrant. Okay, so in both cases, therefore, angle between. Okay, so with that, let me just define the angle between two lines. Okay, if you have lambda of M1, M1, that will be the first direction vector of the first line. The second direction vector of M2, Okay, then cosine theta will basically be the modulus. So remember to take modulus because we want to ensure that we get our cosine theta to be positive. Okay, we want cosine theta to be positive. Only when you take modulus, alright, you are ensuring that cosine theta is positive, and you ensure that the theta is acute.